Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about net ionic equations. And net ionic equations is one of those things that students tend to struggle with when they're first learning chemistry. So please watch this video from beginning to end so that you can become a pro in doing net ionic equations. Now, what we're doing with net ionic equations is we're taking one of the concepts that we already know how to do, which is balanced chemical equations. And what we're trying to do is we're going to decide is each of these chemicals, if we're going to split them up or if we're going to keep them together. And the way you determine if you split something up or keep it together is by knowing your solubility rules. And in the previous video, we described if things split up or if they stay together based on if they're insoluble or soluble. So if you haven't watched that video, please watch that video before coming back to this one. Okay, but let's get right into it. Let's try to decide if each of these chemicals should be split up or if we should keep them together according to their solubility rules. The first one that we're going to look at is calcium chloride. Okay? Now, according to our rules, chlorides are typically soluble except with silver, mercury, or lead. I got calcium here. So this one is going to be soluble. And if it's soluble, that means we split it up. Okay, so I'm going to put an AQ right here, which means that it's an aqueous solution, which means it does split up into its ions. And for every one calcium ion you have, because calcium's a positive 2 and chloride's a negative 1, for every one calcium ion, you're going to get 2 chloride ions. Now, some people will say, hey, Mr. Heffel, I see a 2 here. It looks like it's diatomic. I want to remind you that chlorine is only diatomic when it's neutral, okay, and by itself. Here, the chlorine actually was in the compound. In addition to that, it's charged. It has a -1 charge right here, so it is not diatomic in this situation, okay? The next compound is sodium carbonate, okay? Now, typically, we look at the negative ion, and it's a carbonate, and carbonates typically are insoluble. However, we have a trump card here, sodium, okay? Sodium is an alkali metal ion, and these are what I call trump cards. If you have one of these substances in your compound, it always separates all the time. It's always soluble. There's no exceptions. So when I see this alkali metal here, I don't even really pay attention to the carbonate whatsoever. I know this thing's going to be a solution, okay, because it does dissolve in water, so we give it aqueous. And that means it does split up into its ions. And it's going to make 2 sodium ions for every one -2 carbonates. Okay, because carbonate is a -2, sodium is a +1, so 2 sodium ions for every 1 carbonate ion. So you can see I'm using coefficients to describe how many of these positive and negative ions I have. Okay, let's move on to the next one. Does calcium carbonate split up? Okay, the answer is no, it does not. Carbonates, okay, are typically insoluble unless paired with one of these things that are always soluble, and calcium is not over here. Okay, so it's an insoluble. So I'm going to put an S, and that S stands for solid. Okay, and our solids are insolubles. Okay. And if something's insoluble, that means it sticks together. So I'm going to leave that stuck together. And I'm just going to bring down the S here to remind myself that this is a solid. And we also have a chemistry vocabulary word. We tend to call this the precipitate. Okay. So the net ionic equations that we're doing today, they're going to be called precipitation reactions. And the precipitation reaction just means that a solid is forming somewhere in the chemical equation. Okay. Next compound, sodium chloride. Oh, right here's trump card, sodium, alkali metal, 100%. This is going to be a solution that splits up into its ions. So it's 2 sodium ions and 2 chloride ions. And we call this thing the complete ionic equation. Now, not many instructors are going to ask for this equation. Okay, this is really the work that we have to do to get to the net ionic equation, which instructors do like to ask. Okay, so how do you change a complete ionic equation to a net ionic equation? Is you remove what we call spectator ions. And the spectator ions are just watching the chemical reaction take place. They're really not involved in the actual chemical reaction. And the way you identify a spectator ion is you got to find something that shows up on the left-hand side and the right-hand side. So if we analyze this and we look at our chloride ions, we got 2 chloride ions on both sides. These guys are spectators. They're just watching. Nothing happens to the chloride. It's chloride before and it's chloride after, so just watching. The sodium ions do that as well. We got 2 sodium ions here and 2 sodium ions here. They're just watching the chemical reaction that occurs with the other substances. After you remove the spectator ions, that's what's going to be your net ionic equation. So this equation is really all about calcium ions running into carbonate ions to form this solid calcium carbonate compound. So this is what your net ionic equation is going to look like, okay, after the spectators have been removed. So this is the actual chemical reaction that's taking place, and the sodium and the chloride ions, they're just watching this take place. They're really not involved whatsoever in this chemical reaction. So I really could substitute out this sodium ion for any other alkali metal that's on the periodic table, and the same thing would take place. The calcium ion would run into the carbonate ion to form this solid calcium carbonate. Okay, let's try one more. And what I'd like you to do is I'd like you to pause the video after I write down the balanced chemical equation to see if you can split things up or keep them together based on the solubility rules and come up with the net ionic equation. Okay, so in the second example, we're going to have lead 2 nitrate react with some potassium iodide, and it's going to form potassium nitrate and some lead iodide. So right here, I'd like you to pause the video, okay? Decide, do these chemicals split up or stick together? And when you come back, I'll be working on the problem. Okay. So hopefully you've worked on the problem. Let's take a look at lead nitrate to decide if it splits up or stays together. It's one of the trump cards right here, nitrate, okay? That means it doesn't matter what you pair it with, that nitrate's going to split up into its ions. And we're going to split this up into a positive 2 lead and 2 nitrates. And the reason I knew this was a positive 2 is because I have 2 negative 1s. And to cancel out 2 negative 1s, you'd need 1 positive 2. Okay? Next problem is going to be potassium iodide. Okay? Right here's another trump card. So this has a trump card of nitrate. That's how I knew it was a solution and dissolved in water and splits up. Here it's the alkali metal that tells me that this is a solution and that it splits up. And it's going to make 2 potassiums and 2 iodides. And then it's going to form some potassium nitrate. Now this potassium nitrate actually has 2 of these things over here that are always soluble. Alkali metal and a nitrate, 100%. This is going to split up into 2 potassium ions and 2 nitrate ions. Okay, 2 potassiums, 2 nitrates. Okay, and that leaves us with lead iodide. Okay, if I look over here, no trump cards over here, and I have to look up my solubility rules for iodides. And iodides are usually soluble except with silver, mercury, and lead. And I got lead here. So this guy is our insoluble, okay? We give it an S, which stands for solid, okay? So this will form a solid, and it will not dissolve in water, okay? So it sticks together. We then cross out our spectator ions, which are going to be the potassium ions. They're just watching. Nothing's happening to them. The nitrate ions are crossing out. Nothing's happening to them. They're just watching. So the chemical reaction that's actually taking place is between the lead positive 2 ions that are in solution, and they're reacting with 2 iodide ions that are in solution, okay? And that's going to form some solid lead iodide. And if you ever did this problem in class, it's a really pretty color yellow as far as the solid is formed. And remember, that solid is called a precipitate because these are precipitation reactions, but this is how you handle net ionic equations for precipitation reactions. Now, College Board, who are the makers of the AP test, they not only like precipitation net ionic equations, but they like acid-base reactions and oxidation reactions that sometimes we call redox. Those are the other two that they really like, and those will be coming in the next video. If this information has helped you, please give it a like, subscribe, and add a comment.